Hey guys, Mr. Adamson here again. Today's lesson we're going to talk about acids and bases. So, first thing I'm going to give you a few definitions. So, an acid is a corrosive, sour-tasting substance that turns blue litmus paper red, or red litmus paper it stays red. A base is a slippery, bitter-tasting substance that turns red litmus paper blue, or blue litmus paper stays blue. Now, substances that are neither acid or bases are neutral. Now, when an acid and a base combine, they cancel out each other's properties, and this is called neutralization. Now, an acid is a compound that dissolves in water to form a solution with a pH lower than 7, and we're going to talk a little more about the pH scale. pH scales range from 1 to 14. Now, a base is a compound that dissolves in water to form a solution with a pH greater than 7. Now the pH measurement indicates how acidic or basic a substance is, and recall that a pH is a measure of the number of hydrogen ions in a solution. So, the properties of acids and bases. Acids react with almost all metals. Most bases do not react with metals, and you talked previously about the periodic table, so you know what an acid and what a base is, or sorry, what a metal and a nonmetal is. Now, the easiest way to determine whether a substance is an acid or a base is by determining its pH. Now, indicators. An acid-base indicator are chemicals that are used to determine if a solution is an acid or a base. Now, indicators change color depending on the pH of the solution. So universal indicators, they range in colors, and so you can kind of tell specifically what degree of an acid or a base you have. And you also just have your regular pH strips that you can dip in, and they're going to turn yellow, or going to turn red for acid and blue for base. And a litmus indicator is a chemical derived from a lichen. So this is a plant. It's not a plant-like organism, or it is a plant-like organism. It's not a werewolf. So if you've watched the Underworld movies, they don't get it from werewolves. They come from a plant-like organism. And litmus is usually in paper format. And so that's what we're talking about, litmus paper. They are just turning red for acid, blue for base. Now blue litmus, again, turns red when is in an acid, and in a base it stays blue. Red litmus stays red when in an acid, and in a base it turns blue. And in a neutral solution, such as pure water, litmus paper does not change color. So that's why you have to use both indicator strips, both of these litmus papers, because if you put a blue piece of litmus paper in a neutral solution, well, it's going to stay blue. So you don't necessarily have a base. That's why you test it with red piece of litmus paper, and if it just stays red, then you know you have a neutral solution because they're staying the same colors that they were going in. And again, red equals acid because red has a D in it, acid has a D in it, and blue equals base because they both start with B's. Now the pH scale. The pH scale is a measure of acidity. Most solutions are between 0 and 100. I think previously it said 1 and 14. It's 0 and 14. And a neutral solution has a pH of 7 at 25 degrees Celsius. Acid substances are below a pH of 7, and bases have a pH higher than 7. Now the properties of acids and bases, and this is just a nice little table to show you kind of everything. So the taste, acids are sour, bases are bitter. The touch, acids aren't really slippery, bases are. Reaction with metal. Metal corrodes, hydrogen gas bubbles form with acids, and with bases there is no reaction. Litmus indicator, so again with litmus paper, acids are red, bases are blue. Electrical conductivity. Both acids and bases will be conductive for electricity, so their solutions will conduct electricity. Acids will do it quite well. Bases, they still do, but maybe not to the same degree sometimes. And the pH of the solution, acids are less than 7 on the pH scale, and bases are greater than 7 on the pH scale. This table here just shows a bunch of different acids and bases, so we can look here. We have hydrochloric acid, the chemical formula is HCl, so this is used in toilet bowl cleaners, gastric juices, metal cleaners, make sugar and glue. Carbonic acid, so used in club soda, soft drinks. Sulfuric acid, battery acid. Okay, lactic acid, so this is when you're working out and your muscles start to burn. You have lactic acid building up in your muscles, and that's what's burning in there. And so, I mean, because it's an acid, it's kind of that's the burning feeling you feel. If we look all the way over to the bases, we have sodium hydroxide, so this is in soaps and other cleaners. Potassium hydroxide, this is in making soaps also. Magnesium hydroxide, this is used as laxatives and antacids. So if you are having heartburn and you take an antacid, you are actually ingesting a degree of magnesium hydroxide. Okay, if we go down to ammonia, NH3, this is what you would use to maybe revive an unconscious person. You'd put it under their nose if you see those kind of smelling salts that they use. It's also used as a fertilizer. And then other things such as sodium carbonate and sodium phosphate. These are used in detergents. Now, corrosion. Corrosion, these are substances that are found near either end of the pH scale are highly corrosive. And corrosion is the wearing away of materials by chemical action. And we usually see this as rusting. So think of our vehicles or anything you see rust. This is an example of corrosion or something because of a corrosive material or substance. Now oxygen, and this is important, is the primary cause of this chemical reaction. So example, acid rain. Acid rain is precipitation or rain that has a lower pH than 5.6. And it is from the burning of fossil fuels where the pollutants combine with water in the air, so oxygen, to form acid rain. And this is important from the previous slides where we talked about solubility and diluted products versus concentrated products and the waste that was created because we are burning fossil fuels. We're burning some of those non-recyclable materials, and then we're getting acid rain. If you look in this picture here, you can see these burnt areas in the grass and in the forest here of the trees. Now, salt and humidity are also corrosion examples, and areas near large bodies of water tend to be very humid, so there's a lot of moisture in the air. And because there's a lot of water droplets in the air, the salt from the seawater dissolves these tiny water droplets. And the water and the salt forms a solution that coats surfaces and speeds up the corrosion. If we just go back here, see the salt from the seawater dissolves with the water droplets in the air, so again, oxygen. And we look at this boat here, we can see that the water and the salt forms a solution that coats the surface and speeds up the corrosion. So a lot more rust going on all over this boat here. Also think about it with your vehicle sometimes in hot areas. And then also temperature. Think back to the particle theory you learned about earlier in previous notes. As particles heat up, they move faster and collide more. And these increased collisions speed up all chemical reactions. And because corrosion is a chemical reaction, high temperatures will increase the rate of corrosion. Now, which of these cars would corrode faster? We have one here that's in a hot, humid environment, or we have one here that's in a cold environment. Well, we are probably looking at the one in the hot environment. There's a hotter temperature. If we go back a previous slide, we can talk about salt and humidity, so that's going to combine with the hot temperature. There's going to be more salt in the air. You're going to get this from the salt water, probably the oceans. On this vehicle, it's going to rust a lot easier. Here, this one, we're in a colder environment. No, we are not going to have as much corrosion because the particles aren't going to be moving as fast because of the cooler temperature. But something to also think about, we're in a cold temperature, what do they do to highways? They salt the highways. So we are going to be getting salt on our vehicles. That's why it's really important to wash your vehicle a lot in the wintertime because the salt builds up and it starts to corrode away at your vehicle, especially when it starts to melt. So that's it for acids and bases today. Hopefully it could take a little bit from what I was talking about and with the corrosion examples. And we will talk to you later. Thanks for listening.